Good afternoon, everyone. If we are going to give this just a couple more minutes, and then right at 12:02, I'm going to get started and get the webinar kicked off. We still have a lot of people entering the room, so I want to give everybody a chance. Again, welcome everybody. Everyone has been muted except for the hosts of this webinar. So please use the chat box with any questions or issues, and we will make sure we go through all your questions at the end. I am Sarah Hunt, Director for Dupage County Stormwater Management, and today we're going to welcome Vitas Pavadinskas and Benjamin Krumstock in our webinar about composting. I know I am a different face to see here. I'm seeing the webinar. Don't worry for the next one. When we start our next series, Chris Vonamy will be back with his dad jokes. So everybody can have that to take away from the next series. This is the last webinar of our season, or the last webinar of this year's series. And this webinar is the versatility of compost to capture, clean, and divert stormwater. I am really excited about this webinar. Because I tend to think I live and breathe stormwater. And with some of the stuff that I have seen about composting, I now will find out that I also have a way to eat stormwater as well. So it's all components of my life. And anyone who knows me well knows that eating is probably more important to me than breathing most days of my life. And so with that, I am going to welcome Vitas to start the webinar, start his presentation. And Vitas, you will be able to take control of the screen and always unmute yourself. And at this point, I will mute myself and let you take over. So thank you.
All right, thank you, Sarah. So as she said, our title of our presentation is The Versatility of Compost to Capture, Clean, and Divert Stormwater. So it's going to be an introduction into the use of compost in stormwater management and erosion control. Keeping water and soil on site is a major concern for agriculture, but it is not the only industry on the landscape facing this issue. Agriculture tends to get blamed for a lot of the nutrients and sediments that end up polluting water bodies. To improve water uptake and storage in soil, organic matter content needs to be maintained. So for every 1% of organic matter in soil, an additional 20,000 gallons of water is held per acre. Agriculture has resorted to things like no-till practices or cover cropping, which helps keep the soil covered and organic matter content stable in the soils. Applying compost is another way to maintain and increase the percentage of organic matter in soils, and that practice shouldn't be limited to just agriculture. So we are Benjamin Krumstock and Vitas Pavadinskas, and we are representing the Illinois Food Scrap Coalition. The Illinois Food Scrap Coalition is a not-for-profit organization advancing diversion and composting of organics in Illinois through advocacy, program implementation, marketing and business development, policy, and outreach. We both participate on the Market and Business Development Committee, and our goal right now is to find more end users of compost, doing outreach and education so the public knows the versatility of compost. We're not experts in stormwater management and erosion control. However, we have accumulated numerous resources that we'd like to share that can get you to the experts who have had success utilizing compost in their BMPs. We're not the authors of the books, but you can think of us as the librarians that can point you to where you should go to get the proper information. So Turfgraft management practices like agriculture have been blamed for polluting waterways. Laws have been put in place to limit fertilizer use, and some areas have gone so far as to ban phosphorus application altogether. So Dr. Doug Soldat of the University of Wisconsin did some research where he looked into where phosphorus bans were in place, but it appeared that these bans were not removing phosphorus from the waterways. So during that research, it was found that exposed soil was the culprit for putting phosphorus into the waterways. And so in areas where there were lots of new construction, breaking ground, a lot of exposed soil, that's where you had the highest levels of phosphorus runoff. So the picture above shows a silt fence failing to keep soil on a construction site after a rain event. The water with soil spilling into the street and eventually to a drain. So bare soil on a slope during a rain event can experience things like detachment of soil particles. These particles are transported and translocated in the water. Eventually the soil particles are deposited elsewhere, and sometimes it ends up in a body of water. Compost can be used in multiple ways on the landscape to mitigate these effects. Compost can dissipate rain impact, improve storage and movement in soil profile, which is infiltration, evaporation, capillary action. It can check sheet flow over the soil surface and improve revegetation. The form compost takes will change depending on the application and purpose. So compost is a complex material that provides physical, chemical, and biological means of filtering water. So how does compost filter water? It can physically trap sediments in pore spaces of varying size. It chemically binds and absorbs pollutants such as metals, organic and inorganic compounds, as well as nutrients. And the biology of compost, which means the microbiology, comprises a complex community of microbes which can break down many of the organic pollutants that end up in our soils. Studies have shown reduced bioavailability of metals when the soils have high organic matter content. The opposite has been observed in industrial areas that have been changed over to residential or public spaces. So when these soils are subject to compaction and degradation, the soil particles containing metals like lead, arsenic, and chromium don't have the glue of the organic matter to keep them together and can become airborne as dust to be breathed in or carried into homes or on clothes or through windows or transported by sheet flow during rain events. And what you see here is basically an illustration, a representation of what the structure looks like of compost. It's fairly chewed up and assembled again by the microbes that are in charge of the degradation process. So this graph comes from a 2-day workshop put on by Caltrans and the US Composting Council back in August of 2020. The presenter was Dr. Britt Fawcett of Filtrex International. So compost can be screened and separated for particle size. That means you can get larger chunks or you can get smaller chunks. Application and purpose will dictate whether you want more flow of water, which needs a larger particle size, or more filtration, which requires a smaller particle size. The scale on the bottom is in inches. So it ranges from, on the left, 1/4 inch all the way out to 2 inches in size, which is more like a mulch. Here, Dr. Fawcett has determined you have the optimum performance of flow rate and filtration capacity at a 3/4 inch particle size. In the application, it must be determined if max water needs to be captured or simply slowed down like on the hill slope. Okay, so here is a sketch of locations where compost can be used. I tried to use different textures in the polygons to show different relative compost particle size needed in the different areas of the slope. The goal of compost is to get as much water to first infiltrate as the water hits the ground during a rain event. then slow down, divert, capture the water as it travels overland to its destination. The size of the arrows are a qualitative way of showing what relative amount of water goes into the ground compared to what is still moving along the soil surface. Larger particle size compost on the summit will protect soil from disturbance and detachment, but maximize infiltration. If the particle size is too fine, then infiltration will be slowed and water can collect and sit on top of the soil instead of seeping in. A compost sock right at the shoulder of the slope would have fine particle size compost to keep water and sediment up on the summit, interrupt the water's path, slow the water's speed over the shoulder, minimizing the formation of gullies and rills. In the middle of the slope, compost socks and berms can provide backstops, rooting medium for vegetation. Plants on the slope become a living obstacle to overland flow, and their roots create pathways for water infiltration. At the bottom of the slope, swales or catchments can be built with compost as a component, allowing for rapid infiltration as well as filtration of pollutants. Again, context and purpose is important when selecting the compost. The next two slides provide data from several studies showing how effective compost is in limiting water runoff and capturing whatever is carried away in the water. Here we have studies by Dr. David Crone, who looked at soils on slopes treated with compost blankets after a fire damage. So several treatments of compost were used, which included coarse and fine particle sizes, that's indicated by the C and the F prior to the number of the treatment, as well as a depth, 1 or 2 inches, and whether it was incorporated as well. Biosolids were also included in this study. So what is a compost blanket? A compost blanket is basically a layer of compost usually applied with a blower truck onto the surface of the soil. And this trial took place in the California UC Riverside campus, and winter rain was a source of the moisture, and that's identified by the dates. So the dates indicate the days that it rained, and where they went out to the trial site to measure the amount of water flowing through and the amount of total suspended solids that snuck through the trial site. So the control is bare soil, and soils affected by fire can become hydrophobic and get washed away during heavy rain events. This would be the familiar scenes of mudslides on national news that follow severe rains that fall on fire-affected slopes. So Dr. Crone also captured total suspended solids, also important to control and capture in stormwater. Besides removing solids from the water, these data also indicate little contribution by compost of suspended solids, a worry many managers have expressed when considering the use of compost in their own projects. So what I'm trying to say there is that managers think that compost could potentially contribute as opposed to prevent or capture material. And in this study, it shows that very little is actually coming off from the compost material itself, and it does a lot more to capture as opposed to contribute to the amount of total suspended solids. The information for this slide was taken from the impact of compost application on soil erosion and water quality. It's this 170-page document prepared by Dr. Crone of UC Riverside for the California Department of Resources, Recycling and Recovery. It's a very helpful document for developing BMPs. So the message here is get soil covered. Here, Dr. Fawcett looks at compost blankets compared to other erosion control practices like straw wattles, nets, and tackifiers. The item highlighted in red in the upper right chart is a 2-inch compost blanket, which had some of the best results for varying rain quantities. The bottom chart shows how effective compost filter socks are pulling solids, nutrients, coliforms, metals, and organics from the water. There's concern that compost may release some nutrients into the water is trying to capture, but the numbers show compost captures much more than it contributes. Consider the earlier slide, the complex structure of stable and mature compost that resists breakdown. So Benjamin later will speak about stability, maturity in compost and how it has an impact on compost quality. Again, soil should not be left exposed. It needs to get covered. So the next few slides will be examples of what I tried to illustrate in the earlier diagram of compost application on a slope. So on a summit and places on the slope, a compost blanket can be applied, which can simply be a compost applied in a thick layer exceeding an inch. So here are compost blankets being installed with blower trucks. The compost lays on the surface, does not require incorporation, and a thick layer allows the compost to bond to itself, whereas a thin layer of compost can be saturated and easily washed away. Oftentimes seeds of grass or native plants are mixed in so vegetation can grow and help with the stabilization of the soil. The compost improves seed germination rate and decreases time to germination, which means more plants growing faster, getting established, and holding the soil on the slope. Engineered slopes don't have much organic matter that young plants need to survive, so plants have a harder time establishing. Anecdotal evidence from Caltrans roadside projects speaks to the lack of weeds and invasive species establishing compared to the natives that they put into their projects. And this is another worry a lot of managers have when considering the use of compost. They think that the addition of a nutrient source will lead to the proliferation of weeds. But like I said, anecdotes from Caltrans projects, when they have included native plants and incorporated the seeds into the compost itself, they outcompete the weeds. So here is a study being done in Scotland, very similar to the UC Riverside trials mentioned earlier, where runoff is captured in troughs at the foot of the slope. And there are sensors to measure volume, and samples are collected and sent to lab for testing. So here is a real earnest effort to do more than just offer anecdotal evidence for the effectiveness of compost in capturing slope runoff. They're getting some real serious numbers here. PAS 100, which is at the top, refers to Scotland's classification of compost quality. So BMPs need to be developed from the results of rigorous testing and utilize a consistent quality product. Compost can also be shaped into a berm to be a barrier against sheet flow. A special attachment to the blower hose creates a trapezoidal shape. Again, seeds can be incorporated into the mix and plants will grow in that material fairly easily. These plants will send roots through the compost matrix, creating a stronger barrier. Water will pass through, but much of the water and sediment will be captured on the high side of the berm. This is ideal for slope interruption or bank stabilization. So in the top two images, you can see that this is being utilized near a stream. What isn't pictured is the roadway that is nearby. The impermeable surface of the roadway sheds water to the soil surface adjacent, whose capacity to absorb water during a rain event is overwhelmed. So here in this application, an actual barrier is more appropriate than a blanket. When sheet flow is more aggressive and water volume is larger than average, a compost sock is put in place to perform the function of a silt trap and filter. Particularly useful where nearby construction project has created exposed soil. In these three images, you can see the buildup of the sediment next to the sock, like the smooth areas right here, and we got some ponding happening and some collection of silt right there. Sock holds its shape. It stays flat to the surface of the ground, so there is no loss of integrity underneath the compost sock caused by undercutting action of aggressive water flow. Wooden stakes can be put through the center of the compost sock to give the structure additional stability without compromising its function. Compost socks are available in a variety of diameters. I'll give you more info on this later. And managers need to consider the on-site conditions to determine which diameter will work best to mitigate their stormwater issues on site. So here the compost sock is acting as a slope interrupter. The faint green spots between the socks are seedlings planted to revegetate the slope. This example comes from Australia. Here compost socks of narrow diameter cut across the contours of the slope, creating protected areas for revegetation. A large berm acts as a final barrier, obstacle, or speed bump to prevent a washout or a gully at the base of the slope. The planted seedlings need water, but its delivery needs to be regulated. Compost socks arranged on the contours may rob plants lower on the slope from getting adequate moisture for establishment. So how do contractors know how to install compost socks? Here is a standard plan with technical specs for installing compost socks from Caltrans. Proper staking and securing overlap distance is part of the diagram. A contractor can reference these plans from a Caltrans spec book, as well as installation steps, mixing rates of materials. Input from engineers in the field has prompted changes in the specs to omit lashing and to rely on staking. So lashing is basically using ropes to secure the compost socks to each other. The lashing was carried over from the practice of utilizing straw wattles. The assumption was that the compost socks would behave in the same way straw wattles would when exposed to significant sheet flow on the slope. So when the project managers saw that that was not the case, they eliminated this step, which saved time and material on the project. So you're ultimately saving money. So again, with straw wattles or fiber roll, the lashing was to keep the heavy water flow from washing out the material. But because compost socks are more stable, heavier, they didn't really need the lashing. So it was kind of a redundancy that they could eliminate. So again, that saves money. You don't have the labor costs of trying to get that lashing put into place, and you're not using that material in the project itself. All right, so the left picture here illustrates a large diameter compost sock following the topographic contour of a slope. Above the contour, work is still in progress. Below the compost sock, the slope is graded and ready to grow vegetation. The slope interrupting compost sock are nearly 24 inches in diameter. So these are fairly sizable compost socks here. This slope has only two compost socks, the slope midpoint and at the slope foot. And you can see that here in the background of the picture. The picture on the right is compost seeded with vegetation. At the top of the slope is a roadway. So the plant roots help keep the compost on the slope. The compost helps the plant get established. Both combine to keep water on the slope, clean the water before it enters a stream on the right edge of the photograph. Several rows have been put into place on a short slope due to the volume of water coming off the roadway. Since there is a roadway, there are pollutants carried on the water that also need to be mitigated. This image comes from New Zealand, a project in New Zealand. So as the slopes become more challenging, designers increase the number of compost socks. Again, plant roots and help keep this compost in place, and then also incorporating reinforcing geotextile in the project helps keep the compost and soil in place. So here, compost is literally building a slope. So there are many options available for compost socks. A quick summary of compost sock benefits would be the biodegradable fiber of the sock itself. It can be left in place and no removal or disposal cost. There's no trenching necessary or rope lashover. It can be built for high flow or high removal, so allowing a lot of water or capturing a lot of water. There's a range of sizes going from as small as 5 inches in the diameter all the way up to 2 feet. And it can perform a range of functions such as perimeter control, slope interruption, act as a check dam, or sediment trap. And again, I'm not endorsing this product, but they have a great summary of the product's characteristics. That is important for a manager when making a decision of what would be appropriate for their own project. Slope creation or green walls are at the slope extreme. These are not solely compost or based on solely compost, but there is a significant amount of organic matter, which leads to successful establishment of plants on these green walls. The image on the right is showing a crew filling a compost sock on site using a blower truck. This is coming from Vancouver, British Columbia in Canada. There are limitations to the type of compost that can be employed by the blower truck. Moisture content and particle size have to be considered. If compost is not clear of debris or stones, the blower system can experience significant damage. So this is not to highlight the limitations of the blower, but rather emphasizing the importance of the sourcing and the quality of the compost that's going to be utilized in the project. So now we're getting down to the bottom of the slope, areas where water collects and needs to quickly infiltrate. Again, relying on Caltrans, here are specs for 3 types of catchments. Each utilize compost in some capacity. DPPIA stands for Design Pollution Prevention Infiltration Area. So currently there's no information on service life, but 15 years is the hope. This of course depends on the sediment load. So California and Texas currently have data for water in and out of these installations, so they know what's coming in and what's coming out. They have captured that. Checking how much pollution and sediments are removed by these catchments. So here you have a Caltrans project in a parking lot. The vegetated area has a soil profile amended with compost. Whatever water that does not infiltrate in the green space travels by sheet flow to the trap in the stony area at the bottom of the picture. The left picture is at the time of construction, and the right picture is sometime after the establishment. So there are resources available from federal sources that can recommend BMPs. The left coming from the American Association of State Highway and Transportation Officials, U.S. Army Corps of Engineers. And the right comes from the National Resource Conservation Service. And these are specific to compost sock, filter sock utilization. Here we saw on the left this resource earlier when we were talking about Dr. Crohn's research on fire affected slopes. And the right is actually a new toolbox from the Caltrans website. So it's an erosion control toolbox for compost. And it's an excellent primer for those who are new to compost use in erosion control. This is taken from the same toolbox I was just talking about, just further down. Soil moisture depends greatly on the organic matter content. And I like how they organize data here that is significant for a manager to know for planning a project. CY refers to cubic yards and AC is for acres. And so these are sort of standard depths or application rates of 2 inches, 3 inches, and 4 inches. And considerations are how much nitrogen, which is total N, being applied per acre, availability of that nitrogen, what is your application rate per acre? So it's 540 cubic yards at the highest rate at 4 inches. And what does that translate into tonnage, which is 216? And you're trying to achieve a range of 8 to 13% in the soil. So this is not an endorsement, but an example of a compost company, McGill, which operates out of North Carolina, as well as Ireland, describing how they are incorporating compost into a strategy to rehabilitate stream buffers. The idea is that the compost helps the soil with water issues and helps native plants thrive where organic matter had been depleted earlier. And then another instance of using compost to help establish natives in sensitive areas, improve water quality, and reduce nitrogen and remove suspended solids. So this is an EPA write-up that dates back all the way to 1997 and refers to local work on the Des Plaines River. Again, the authors speak of the decrease in organic matter in soils in these sensitive areas, leading to poor soil quality that cannot sustain vegetation to provide ecosystem services. So here is some more data on material itself. So managers may be interested in how much does this stuff weigh if I order it when it shows up on a pallet? What is the total cost? So the Texas Commission for Environmental Quality put out a report some time ago that the cost of a 12-inch diameter compost filter sock would range between $1.40 to $1.75 per linear foot. So if you're trying to budget for this project, so we talked about the specifics of what the compost sock does. Now, okay, how much is that service going to cost me? So here, about a decade ago, the Texas Commission evaluated it and saw that between $1.40 and $1.75 is the linear foot cost. The cost for an 18-inch diameter sock used as a check dam runs from $2.75 to $4.75 per linear foot. So again, these are considerations. If you want to adopt these practices, there's obviously a cost. So this chart is taken from EPA document that was prepared by Green Spaces. This is basically a cost calculator, and it's designed to help landscaping construction companies estimate the cost of using environmentally beneficial compost filter berms or compost filter socks for erosion control, rather than just conventional silt fences. The cost calculator demonstrates that environmentally preferable erosion control methods are very cost competitive for all project sizes and durations, and that they offer significant savings for projects that run for more than a few months. So here they basically break down on the low end and on the high end what it would cost to run things like a 1x2 foot compost berm, a 12-inch filter sock versus your standard or conventional 3-foot silt fencing. And in conclusion of my presentation, here are some references and resources that I use in this presentation, and this should direct you to more information on the topic. So I will now hand off to Benjamin, who will continue the presentation discussing compost sourcing, quality.
Okay, can you see that all? Okay. Hi, thank you very much for having me. It's a pleasure to be here. Benjamin Crumstock, serve as president of my own startup, as well as the chairman of the Illinois Food Scrap Coalition. If you're not familiar with us, we can be a great resource. I see some questions already coming in on the chat, and a lot of the information that you're looking for is on our website. If not, there are links to other resources, as well as people within the IFSC who can get you to those sources. So I want to start off by just saying, whoops, going backward, previous, that compost is not a single entity. There are different types of composts, different screen size, and screen size, we'll talk about the size, the maximum size of the hole that the compost is screened through at the end of manufacturing. And as Vitas pointed out, different screen sizes warrant different or are applicable to different types of projects. So these are all composts. They have different feedstocks, different materials that make up those products, different types of let's say, length of composting, duration of composting, and then the result is a different product with different characteristics. Having said that, compost is not mulch, and mulch is not compost. So it's important to understand that compost is compost, but compost is composts, plural. When it comes to getting a handle on quality, what is a quality compost? The answer is there is no single definition of what is a quality compost. It really is dependent upon the intended use and the location of that project. So the source soil or the project soil is important. And what is a wonderful product, a wonderful compost for one particular application in a setting with a particular soil profile, maybe the wrong product for use in another. So as you consider which compost to purchase, I'll ask you to consider a few things: intended use, the goal, the effect. Are you doing a stormwater mitigation project where the sock is appropriate, or are you going to remediate a field? It could be your public, it could be your public assembly point. It could be a park district property where the soil has just become green concrete and you need to remediate. Those are different applications. They're going to take different composts, and it's going to be valuable to think of that in advance so you get the right product. Application rate and deployment method. So again, are you going to incorporate deep? Are you going to truly have an engineered soil essentially, or is this going to be a top dressing, or are you going to use this in a sock context? Site characteristics. Again, considering slopes that were in play in Vitas's presentation. And again, the soil profile itself. Are you in a place where your nitrogen is adequate? Are you in a place where you're really trying to supplement nitrogen, but you want to consider that actually you may actually be prudent to do multiple applications so that you don't take the P or the K and tip those out of whack and create a nitrogen runoff. Different characteristics or a P runoff. So different characteristics of the soil that you need to consider. Feedstock, somebody asked in the chat, what is compost made of? Well, the answer is it depends which compost. If you are in the typical compost facility in the state of Illinois, permitted compost facility in the state of Illinois, it's predominantly landscape material, farm residuals and landscape materials, the leaves, the grass. But manure is a feedstock, food scraps are a potential feedstock. So the recipe of that particular feedstock or that particular compost pile will determine the characteristics of that final product. Screen size, again, the maximum size of the particle in that pile of compost, that's going to make a difference. And then the nutrient profile. Again, going back to the feedstocks, food scrap amended compost is going to have a different nitrogen profile than just landscape profile or predominantly leaf composted profile. Again, I said that compost is not mulch, and it's really important to know, is this compost or is this something that looks like compost? And the critical question here is, has the composting process been performed and performed completely and properly? There is an actual science to composting. There's a microbial process. This is a degradation by biology. and you can't rush all of it. You can encourage some of it, but if you don't take it through the complete process, it's not compost. And if it's incomplete, it has some potential downsides for you. So the U.S. Composting Council does have a definition of compost. I'm including it here. It's something that was created in association with and adopted by the AAPFCO. If you're not familiar with them, that's a national association that all the different states, actually all 50 states, have representatives to, and they're the ones who are regulating fertilizers at large. And this is a true definition of compost. So which compost is the right compost? It's a trade-off. There are different characteristics to the compost, and depending upon what you're interested in, you have to make a decision. 3 buckets: safety and risk, the product itself, what herbicides might be residuals within that compost, what trace metals, so what nutrients, what nutrient profile, aesthetics. You know, can you tolerate a few stones that get through the screening process, or is that a deal breaker? In a sports turf context, maybe that's a deal breaker. In a roadside project, you know, not applied by a blower because you don't want to damage the equipment, maybe those stones are acceptable. And then what is the profile of the soil that you're working in, and what is your ultimate goal? So you're going to have to balance. And just to make it dramatic, these are different applications, and you'll see with 4 checks being the most important criterion and 1 check being the least important criterion, depending upon what your project is, different profiles, different parameters are more or less important. So in the erosion control context, that's the second line, the nutrient content isn't really an important consideration. If you take it to the agricultural context, it absolutely is. If you take it to a turf grass context, it absolutely is. So how do you know you're getting high quality or properly manufactured compost, and getting information about what that compost is? So I'm brand neutral. I'm going to share the U.S. Composting Council's Seal of Testing Assurance program, because it is the national program that's available to help you find a product that has been tested appropriately and guaranteed. Having said that, if you have a composter who's doing good work and submits their material to testing, this USCC STA is not mandatory. You can use those same labs or other high quality labs to test the compost, and you can be guaranteed that you're getting a good product if they match the portfolio that you're looking for. So it's mostly an information resource with only 2 pass-fail criteria. And in this case with USCC STA, you're going to get standardized testing protocols and you're going to get standardized reporting. So they're looking at physical, chemical, and biological compost characteristics, and that's important. The USCC created a test method, TMECC, and that's a standardized test method that's applied and used by all of the different participating labs. What you get from a composter is this compost data technical sheet, the CDTS. There are a number of parameters that are reported. And again, except for 2 parameters, it's all information, not pass-fail. In order to meet, you do have to meet US EPA testing limits for heavy metals and pathogens. So that is going to be a pass-fail. And then you get a second sheet, which includes specific directions for the product use and information about the feedstock. So this is the 2-page document. This is what a sample USCC CTDS looks like. This is a mag of the information on the first page. You have the parameter reported as, so you have your units and the results. And again, if you look down to the select pathogens and trace metals, here it's a pass-fail with those particular standards set, and the rest is reported in units, but you're going to be able to determine if this compost meets the profile that you're looking for or not based on satisfactory testing. Specific directions for product use, there's no rule about that, but the composter might tell you this particular product is ideal for stormwater management, or it might be ideal for agricultural uses, or it might be ideal for turf management. There's opportunity for variability in there. And then the compost ingredients, they'll share what feedstock went into this. Is this manure? Is this grass? Is this food scrap amended? Important information, there are two bits of vocabulary I want to share, stability and maturity. So they're both difficult concepts for people to grasp. I've struggled with it for a while before I think I've finally gotten a handle on it, but they're critical. So stability is the state or stage of organic decomposition. Think about it as the degree of resistance of that feedstock, of that core organic material that you put into the pile, to then continue on the pathway of decomposition. A highly stable product is very unlikely to undergo further decomposition. So it's basically finished, right? You can see a measure or representation of stability in biological activity. If you think of the microbes that conduct the composting process, they breathe, they release CO2. If you have CO2 emission from a pile that drops off, that's likely an indication that there are fewer microbes because there's less food for them to interact with, and therefore, therefore they are absent. The process is completed, and there's a test called respirometry. There we go, which is the test of stability, respiration measurement of CO2. And most compost uses require at least a stable product. Maturity is a little bit more difficult to understand. And here it is a measure of completeness of the composting process. But what it's actually telling you is, are there almost what could be considered transitional compounds within the compost product? Free ammonia, certain organic acids that are part of the transition from your feedstock to your finished, stable, mature compost product, they're in there. A mature compost will not have ammonia or a good amount of ammonia in it. And that's important because some of these organic acids, the ammonia, they can actually be phytotoxic. They're going to kill your plants if you try to lay them down when they're immature, and they can also have odor. So you want to be aware of maturity here. It may not be necessary in all applications, but most require at least a mature product. And the one single most important fact I want to send you home with, or idea that I want to send you home with, is if the vendor you're speaking with will not provide up-to-date compost testing results, then you're unlikely to be purchasing or using quality compost. The people that Vitas and I are in contact with and in relationship with, they're responsible and they're testing their products so that you have a good experience and want to come back with success stories and understand the value of the product. So if they won't tell you, be suspicious and potentially push harder or walk away. I'll just take a brief moment to just mention organic versus organic. People often ask, do I need organic compost? What is organic compost? So all compost is little o organic. It comes from organic matter, but only some is capital O organic. So the capital O is organic certified or required for those farms and other programs where they're using USDA National Organics Program guidelines. Most projects don't require capital O organic. If you're in a community where the residents are interested or concerned and want to spend the extra money, potentially, it may not be more expensive, it may be the same price. But if there's an interest in that particular product, then you may choose to do that to meet their interests. And what makes capital O versus lowercase o, it's this National Organics Program. They have a list of materials that are acceptable on organic farms and what is not. So any manufactured product, so plastic bags that are compostable, they're actually not acceptable in a capital O organic feedstock that goes into compost. OMRI, the Organic Materials Review Institute, is a name that you may see as a certifier of or a lister of organic materials, but they use the NOP list. So they're not generating products. If you're angry because you can't find, because your plastic bag is compostable but is not acceptable in NOP, that's not OMRI's fault, that's the NOP. So I'll close there, and Vitas and I will welcome questions.
Thank you, Benjamin. Thank you, Vitas. You guys took my glory away from me answering most of the questions during your presentations. But it's always appreciated to hear it during the presentation. And so I am going to read a couple of them. I know you went over it as well. One of them was where can we find out where can Dupage County residents obtain compost? And Benjamin did put a information within the chat box on that at the illinoiscompost.org. And so I just wanted to read that aloud in case everybody is not reading the chat box. That way we all have that information as well. Going through most of these again, I do believe you guys answered most of it. Angela Lavernier had a specific question about the jute material. The jute material kind of relates to a presentation most of us sat through earlier today regarding decomposing material and biodegradable material. And so if we can just go through that again and kind of reiterate that question. The question was, are there compost socks available that 100% that are 100% biodegradable made with jute netting or similar material?
Yes. So the idea is that these are going to be permanent features on the landscape. They are not meant to be removed like straw wattles or silt fences. So the material does degrade over time. It acts as, let's just say, a stabilizer for the compost until it gets incorporated into the landscape. So you don't consider it as a static picture. You consider it as a process where the compost socks hold the compost, allows for vegetation to come in, establish, and it just becomes a feature. It just blends in. And then over time, that compost sock will degrade, but overall that structure is maintained because you have the vegetation and the compost over time. So getting back to the topic of maturity and stability, a worry that a lot of managers have with compost is that, well, it's organic material, it's going to break down, it's going to disappear. But that's where the stability and maturity come in. When you have material that's gone through the composting process, it's fairly stable. It's not to say that it's going to last for a long time, but for the given lifetime for a project, let's say 10, 15, 20 years, it'll be there. It'll last. Plus, when you have in vegetation fixing itself to the project, in itself, it sort of replenishes the organic matter in that interaction. And I think I'm kind of getting too deep into that question, but yeah, compost socks, those compost socks are meant to break down over time. And again, you have to think about it as a process that takes decades, because that's the idea of the project, not a static thing that, next week you come back and it's gone. So.
Okay, thank you. And one of the next questions is, do you know how worm composting compares to regular composted material?
So vermicompost is a different process. It's not the same as compost. It's a great product. It's going to be a different product, more likely to be good for the agricultural applications and less likely to be ideal for a stormwater management application.
Thank you. The next question is, why aren't you concerned about phosphorus from compost leaching into surrounding water bodies over a long period of time?
So I wanted to grab one and combine a couple of questions there, because
Sure.
somebody asked about toxins and as well.
Yep. Yep.
And the answer is that, to broadly answer the question, and Vitas will cap it off, what you put into the compost pile can come out of the compost pile, right? And that's important to know. There are a few differences in the feedstock versus product at the end. And it has to do with a few different things. First of all, some of the microbial action can actually degrade these compounds. So there are a few persistent herbicides, but the typical herbicide, so a lot of these chemicals that go into the feedstock, into the pile, by the end of the process, they've been broken down into constituent products and are not recognizable as the base product. So that includes different pharmaceuticals. It includes other chemical products. The other is that there's the act of chelation. So some of these products, the heavy metal, some of the heavy metals in particular, while they're introduced as feedstock, they're chelated, they're bound. So they're not available to the soil, to the grasses, to the produce that's grown in those soils. So there's another element of chelation there. When it comes to the phosphorus running, the same thing. There was a campaign, I mentioned AAPFCO, they ran a campaign, the USCC and some others ran a campaign to be able to label compost as slow P. The particular state of the phosphorus in its bound state is a slow releaser. So it's less likely to come out of that soil and to have a runoff than if it were in a chemical fertilizer context. So it's less concerning. Again, when you look at your project, you need to look at your profile of the soil and look at the profile of the compost and decide if you are tipping something too high and need to be cautious. And I'll let Vita supplement with whatever.
Yeah, so referring back to earlier in my presentation with Doug Soldat, Dr. Doug Soldat out of the University of Wisconsin, a lot of the phosphorus that's ending up in our waterways is coming from exposed soil being washed off the landscape. And so phosphorus is one of those nutrients, one of those elements that binds very quickly to soil. And it becomes available when it leaves the soil and enters the waterways. So you have to think of this as a process, again, not a static picture. So how do you keep soil on the landscape is you keep it from washing away, drying out, blowing away with the wind. Organic matter, like compost, is meant to stabilize the soil. So if you keep the soil in place, you're keeping the phosphorus in place. So you are introducing phosphorus to the soil, additional phosphorus with the compost, but again, it's an issue of stability. If everything stays in place, organic matter percentage is high, moisture content is high in the soil, that phosphorus is going to be staying put. Once things dry out, once things degrade and you reach a certain percentage of organic matter that's low and it's no longer the glue that holds the soil particles together, then that's when you start having phosphorus travel off the landscape and causing problems. So referring back to agriculture, that's why farmers are getting away from tilling practices, which opens up the soil. It degrades the organic matter, which is the glue, and then allows for water events, rain events to wash that soil off the landscape into water bodies, and that's where the problems occur.
Okay, and the next question, kind of going through, thank you, that was a lot of information.
Sorry.
The next question is that, a lot of us haven't seen these products in this area. Are there companies that will spray compost, or I'm sorry, are there companies that will spray compost similar to spraying hydroseed in the area?
You want me to jump on that, Benjamin?
Yeah, I was going to say, through some of the composters actually laying the compost down, there are a few services in the area, in the metro area, that do have expertise in actually doing large scale applications with I can't speak to what particular machines they have, whether there are blowers in the neighborhood, but the idea of the hydro seed, that concept is exactly what Vijay is talking about. There are applications where they'll blend in the compost and a seed mixture, whether it's grasses or other types of plants, whatever foliage, and apply that all at the same time. So that is something to explore.
And
Okay.
one
Oh
frustration.
yeah, go ahead, Vitas.
Sorry, it's one frustration that I have is that the Midwest is got a dearth in those kind of businesses. So Canada has a bunch, the East Coast, West Coast. So it is a region. There are regional differences on availability of these kind of niche businesses. So I've worked on a bunch of projects where, yes, we have compost. They end up bringing a large truck and they dump it at the customer site, and the customer is then stuck to whatever technology that they have to apply it. And oftentimes it's just a few guys with a rake. And that can be very labor intensive and not very efficient. So a lot of the compost generators, that's it. They just generate the compost. They don't necessarily have the technology available to finish off and apply it for the customer. And like I said, it's demand driven. So if we have more interest in compost use, in top dressing, in blanket applications, then I think you're going to have more businesses that will either dedicate themselves to that or expand what they have current offerings. So right now you have to go to like big rental companies, construction kind of things, and get top dressers. And that's pretty much the limit that we have. So you have park districts that will use it on their sports fields. They'll rent out big machinery. But the hydro seeders, that's still pretty limited. And that's talking to the guys who actually build these machines. They said, yeah, most of our trucks are out on the coasts. And we don't see too much demand for them through the Midwest.
Okay. Well, thank you guys. That was a lot of really good information. Maybe created some post-college scares for me of chemistry class, but still appreciate it. And just a reminder to everyone, we will be emailing out the presentations to everyone who is signed up for this webinar. And again, this is the last one of the series. Thank you again to our presenters, Benjamin and Vitas. We really appreciate it, and great job, guys. Fantastic.
Thanks for having us.
Yeah, thank you.